In this video, we'll go over the answer to question 7 of the 2021 New South Wales HSC Chemistry Exam. This question asks, methanol undergoes a substitution reaction using hydrogen bromide. Compared to methanol, the product of this reaction has a lower boiling point, lower molecular mass, greater solubility in water, or different molecular geometry at the carbon atom. In the reaction, the methanol's hydroxyl group will be replaced by the bromine, forming bromomethane as the product. Being polar, there will be dipole-dipole forces between the molecules. However, methanol, having a hydroxyl group, will also have strong hydrogen bonds. With stronger intermolecular forces, methanol has a higher boiling point than bromomethane. Therefore, option A is the answer. The other way to answer this question is to eliminate all other options, which we will do now. We can start by writing out the equation. It's a little clearer if we draw out the functional groups, the hydroxyl and the bromine, to show how effectively in the reaction we have a switch of the OH and the Br, where we see the methanol becomes bromomethane. We can eliminate option D by looking at the shapes of these molecules. We can see that both the methanol and the bromomethane have a tetrahedral structure around the carbon atom. All the valence electrons around the carbon are paired with other atoms, forming 4 single bonds, each repelling each other and leading to the tetrahedral structure. We can see this a little more clearly if we take the methanol, rotate, and superimpose on top of the bromomethane. Therefore, we can eliminate option D. To eliminate option B, we just have to look at the atomic mass of the bromine and the hydroxyl groups. If option B was correct, then the bromine would need to have a lower atomic mass compared to the hydroxyl group. We can see that bromine is 79.9 atomic units, while the hydroxyl group is only 17.008. Therefore, when the bromine substitutes the hydroxyl group, you get a larger molecular mass, not a smaller one. Therefore, option B is not the answer. Lastly, we can consider solubility in water by looking at the intermolecular forces. Water has strong hydrogen bonds and therefore will be able to dissolve molecules with greater polarity more easily. Bromomethane is a polar molecule, but has only dipole-dipole forces between its molecules. When dissolving in water, the attraction is strong, but not as strong with other molecules that can form hydrogen bonds. Methanol indeed has strong hydrogen bonds between its molecules. When dissolving, the methanol molecules will therefore have a stronger attraction to the water molecules, which can form hydrogen bonds. This stronger attraction means the methanol will dissolve more easily compared to the bromomethane, eliminating option C as the answer. These are the references used in this video. Specifically, the chemical structure diagrams come from Wikimedia, with Schell and Hogan's Surfing Chemistry and Blackman et al.'s Chemistry as the other sources. Schell and Hogan shows the results of an alcohol substitution reaction with a hydrogen halide, in this case chlorine, which verifies that bromomethane would be the product for question 7. It also shows that alcohols have generally larger boiling points compared to alkanes, for example, and that hydrogen bonds exist between alcohol molecules. In Blackman et al., the large effect of hydrogen bonds on boiling points is highlighted by referring to a series of hydrogen compounds, highlighting that nitrogen, oxygen, and fluorine atoms fall outside the general trend. These are also good references to establish the tetrahedral structure, showing the theory of molecular shape based on electron bonds and pairs, and examples to show the shapes as well. Thank you for watching and see you next time.